Okay, we are going to look again at angles and radians and degrees today. So I want to remind you, first of all, that there's 360 degrees in a circle. And when you are using the unit circle or any angle in trigonometry, that this is your starting position. It's called your initial side. If you take and you rotate the angles this way, which is counterclockwise, you generate positive angles. And if you go this way, which is clockwise, you actually generate negative angles. And of course, you can go all the way around that circle more than one time to get angles that are bigger than 360 degrees or smaller than 0. There's some key angles that are on the unit circle, if you remember. And they are 30 degrees, 45, 90. You can read as you go through there. And again, um, any one spot that you go to could be called a number of things. So for instance, if I go to this spot right here and I rotate the direction that I did, that would be called 90 degrees. But if I go there by, excuse me, hang on, this is not working for me. It's not anchoring for me like I want it to. So let's see if we can get this to work out here. There we go. If I get there by going like this, where I go all the way around the circle and get there by doing that, that would be called negative 270. Or if I go all the way around more than one time, there's 360 plus 90 more, that would be called 450. So any one spot can be called a number of things depending on how you get there. We are going to look at some angles, first of all, really quickly that are in degrees, and just be able to sketch them, okay? This is a 200-degree angle. Here is my starting position, and you can think of 200 degrees, 180 is halfway around, so 200 is going to be just a little bit past that. And that's how I would draw that angle. I want you to show me which direction you're rotating. So 200 degrees should look something like that, okay? Negative 80. Again, let's start right here. 90 degrees is a 90-degree angle, a right angle. So 80 degrees is going to be slightly short of that, and it should look something like this, rotating this direction. Okay, and then a 400-degree angle. What that means is I'm going to start here. I will rotate positive direction. This is 360. And to get to 400, I have to go 40 degrees more. So I'm going to end up looking something like that. Okay. And then negative 450, I would go across and I would rotate this direction. So there's 360 plus 90 degrees more is 450. So it should look something along those lines. Okay, and then I would just want to remind you also that in 1 degree there's 60 minutes, and in 1 minute there's 60 seconds, and we'll use that in some problems in a minute, but for right now we're going to ignore that. We now want to go to radians. Remember that radians is a unit of another unit of measure to measure an angle, just like you can measure distances in inches or centimeters or feet, or whatever. You can measure angles in degrees and in radians. So, I do want to have you picture, if you remember, think about this as a circle, okay? And if I measure the radius of that circle in 1, 2, 3, 4, 5 little humps, I go that same distance along the outside edge of the circle. The angle that I generate when I do that is called 1 radian. All the way around the unit circle in radians is 2 pi. Okay, all the way around the unit circle is 2 pi. Halfway around the unit circle is 1 pi. And here's the measurements that you're going to use if you want to be able to convert from radians to degrees. Okay, so here we go. This one is asking me how many radians are in a 135-degree angle. So I am going to multiply that by pi over 180. And then you can go ahead and reduce that 135 over 180 fraction on your calculator and get an answer for that. And, sorry, I got distracted. You should get 3 pi over 4. Okay. So there's that. The next one, how many radians are in 115 degrees and 24 minutes? 115 degrees and 24 minutes is not 115.24, just so you know that. It is not that. But 115 degrees and 24 minutes is 154 out of 20, and there's 24 minutes out of a possible 60 minutes in a degree. So 115 plus 24 sixtieths ends up to be 0.4. So this is 115.4 degrees. Okay, and this time I have it in degrees and I want to get it into radians. So again, I will multiply by pi over 180. And you can reduce that 115.4 over 180 if you want and just leave it as a fraction, which would end up being 577 pi over 900. Or you can multiply it all out and just get a decimal. And when you do that, you should get about 2.01 radians. Okay. All right, and then this one I gave you in radians, and I want you to give it to me in degrees. So I will multiply by 180 over pi. The pi's will cancel, and I can just multiply 7 times 180 and divide it by 6, and I should get 210 degrees. Okay. All right, we want to be able to generate the unit circle ourselves without having to, well, we want to have it memorized is what we want to have, is what we want to do, okay? So I need you to remember that all the way around on the unit circle is 2 pi and halfway around the unit circle is 1 pi. So I'm going to have you start with kind of your 45-degree angles, and I want you to realize that halfway around the circle, that distance is pi. We are going to cut that 1 pi into, there's 1 section, 2 sections, 3 sections, 4 sections. So you can see that this is 0. If I've moved to this spot right here on the unit circle, I've moved 1/4 of that pi around. So this is pi over 4. This is 2/4 up here. Well, 2/4 is the same as pi over 2. And then this would be 3/4 pi, or 3 pi over 4. Okay. This is pi, which is technically 4 pi over 4. And then hopefully you can see that you're going to keep going up by fourths. This would be 5 pi over 4. This would be 6 pi over 4, but 6 pi over 4 reduces to 3 pi over 2. And then this, of course, is 7 pi over 4. And we're back to 8 pi over 4, which is the same as 2 pi if we go all the way around. Okay? So that's our pi over 4 increments. And then we can go ahead and do our pi over 6 increments. Again, if we think about this as pi and we divide this into 1, 2, 3, 4, 5, 6 sections, this would be 0. And I'm going to keep counting up by sixths. So I've gone 1/6 of that pi right now. So this is pi over 6. This would be 2 pi over 6, which reduces